Good day, students. Today we are considering a topic titled Wave Nature of Matter. Albert Einstein succeeded in explaining the photoelectric effect by making remarkable assumption that energy of light beam travel through space as concentrated bundles of packets called photons. Experiment on photoelectric effects led to corpuscular nature of light. Louis de Broglie, the French scientist, came with a good study that he carried out that light energy behaves like a wave because of the properties they exhibit, like reflection, refraction, and diffraction. And also, he stated that in the course of the experiment, he stated that wavelength of the light energy is equal to Planck constants over mass of the electron multiplied by velocity. You can see it. Louis de Broglie, the French scientist, suggests that light energy behaves like a wave because it exhibits reflection, refraction, and diffraction, which essentially uses features of waves. He later stated that the wavelength of the waves along with the particles were given as h, a lambda wavelength equals h over p equals h over mass of electron times the velocity, where wavelength lambda is wavelength in meters, h is Planck constant equals 6.63 times 10 to the power minus 34 joule seconds, v is velocity of the electrons, me is mass of the electron, which is equal to 9.1 times 10 to the power minus 31 kilogram. These are constants. Look at the experiment, electron diffraction experiment. This is the hot filament, this is the electron gun, this is the electron beam, this is the thin metal film or crystal. Is that okay? And this is the diffraction patterns that's being incidented on a photographic plate. Now, as you increase the velocity of the electron or the hotness of the filament, when you increase the hotness of the filament, it increases the velocity of the electron. Is that okay? Likewise, and when is incident on electron beam is being incidented on the crystals, is that okay? Each electron will be will increase in the magnitude of the movement and also being transferred to the photographic plates. Each atoms of the electron, each of them will carry the energetic power from the filament. Is that okay? The electron beam is incidented on it, and also the diffraction will be incidented on the photographic plate. Likewise, you can now see the diffraction pattern. The particles such as electrons have wave particles, e.g. X-rays, with experiments. Compton show that the conservation of momentum and energy were obeyed when X-rays were incidented on the electrons. Is that okay? Now, de Broglie stated that particles like electrons have wave nature, and according to Einstein's equation, Albert Einstein, energy equals to mc squared. M is mass, c is the velocity of the electron. Okay, according to Planck, he said after E, energy equals to hf, Planck constant multiplied by the frequency. We now equate Planck's Planck equation with the Albert Einstein equation. Albert Einstein equation is energy equals mc squared, while Planck's equation is E, energy equals to hf. Equating equation 1 and equation 2 together, you have hf equals to mc squared, where c, velocity, equals f lambda, frequency times wavelength. Make f the frequency subject of the formula, you have f equals to c over lambda. You divide both, you cancel c cancel each other, you are left with h over lambda equals to mc. Okay, now you cancel. Okay, what you do here is that you cross multiply. When you cross multiply, mc lambda equals to h. Divide both sides by mc so that we will be left with wavelength. You have wavelength equals h over mc. Now v equals to c equals to velocity of the electron, and wavelength equals h over mv, that is the momentum, equals to h over p. That's wavelength is inversely proportional to the momentum. Please take note. Lambda wavelength equals to h over mv, which is equals to h over momentum. Momentum is mass times velocity. Wave particle duality. It refers to the idea that light and matters, e.g. electrons, have both wave and particle properties. That is, light behaves either as a wave or as a particle, but not as both simultaneously. When you are defining it, you tell us that the wave particle duality refers to idea that light and matter, e.g. electron, have both wave and particle properties, but they behave either as wave or as a particle, but not as both simultaneously. That's wave particle duality. Now, the uncertainty principle. Heisenberg uncertainty principle states that it is impossible to know accurately the exact position and momentum of a particle simultaneously. You can't know the exact position and the momentum of a particle simultaneously. What do you mean? An object is moving, a particle is moving. You want to know the position and want to know the momentum? No, at the same time, no. You either know position or either momentum. That's what it's saying. Heisenberg uncertainty principle states that it is impossible to know accurately the exact position and momentum of a particle simultaneously. The uncertainty in the momentum multiplied by the uncertainty in the position approximately equals to the Planck's constant. You can see H. Now, uncertainty change in P dot uncertainty in the position is greater or equals to Planck constant. Momentum and position, energy and time, velocity and position. Please take note, momentum goes with position. You can see you use delta x for position, delta p for momentum, energy delta E, and time delta t, velocity delta v, and position delta x. You can see delta E are known, the pair are known as complementary variables. Is that okay? Delta x, which is distance, position, multiplied by momentum, greater or equals to, okay, since momentum comes first here, let's call it delta p multiplied by delta x, okay, greater or equals to h, Planck's constant, and delta E multiplied by delta t, greater or equals to h, delta v delta x, greater or equals to h. Now, Bragg's law of diffraction is stated that the diffraction of X-rays is studied. Okay, Bragg's law of diffraction is studied the diffraction of X-rays and stated that when monochromatic X-ray, this monochromatic X-ray, okay, X-rays impinge upon the atom in a crystal lattice. Atom in this crystal lattice, each atom acts as a source of each atom in the crystal lattice acts as a source of scatter radiation of the same wavelength. Source of scatter radiation of the same wavelength. Is that okay? And also act as the reflecting plane. See how it now scatter the electron, or it now causes the electron diffraction on the photographic plates. That's Bragg's law of diffraction. In the next class, we are going to be solving problem on the Broglie equation. This is the end of our class. Please subscribe to my channel so you can have access to the latest video. Have a wonderful day.